Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
There's one more piece of information we must revisit before we can actually start building our next layer of our unit circle, and that is these special right triangles. You may remember these. This is a 45, 45, 90. And what happens here, because it's isosceles, because these base angles are the same, that means this leg and this leg have exactly the same length, and then this is the hypotenuse. So the relationship is that whatever the shorter legs are, they're going to be exactly the same, and then whatever that is, if you multiply it by radical 2, you'll get the length of this side here. So the shorter leg is x, and the hypotenuse will be whatever the shorter leg is times radical 2. Now this is a 30, 60, 90 special right triangle. It will not have any sides that are the same like the isosceles right triangle did. But it does have two different types of legs. The 30-degree angles is the shorter leg, so the side opposite of 30 degrees is the shorter leg. The side opposite the 60 degrees is considered the longer leg, and the side opposite 90, of course, is the hypotenuse. Here's the relationship. The shorter leg, we're going to start with that. We're just going to call x. Now, the 60-degree side, okay, so the longer leg is whatever the shorter leg is times radical 3. And whatever the hypotenuse is, wherever that's at right here, it's going to be the shorter leg times 2. So notice in this particular situation, the longer leg and the hypotenuse depend on what the shorter leg is. So to recap, the shorter leg is x, the longer leg is whatever the shorter leg is times radical 3, and the hypotenuse is double the shorter leg. So using these relationships of the special right triangles in conjunction with our idea here with connecting coordinates to trig identities, or excuse me, trig ratios up here, we can actually build another layer onto our unit circle.